Good morning, my name is Drew Butler, and today I will be presenting my final project in embedded systems, autonomous control of a greenhouse microclimate. The motivation for this project arises in part due to the rapidly increasing demand and prevalence of fresh organic produce. Additionally, home gardening has been gaining in popularity as more consumers choose to bypass rising supermarket costs in favor of growing their own produce. This approach does come with its drawbacks. Unpredictable weather has been the bane of agriculture as long as humans have tended crops. Additionally, pest control becomes problematic with more consumers choosing to avoid poisonous insecticides in their food. These pitfalls may be avoided by the use of a greenhouse to create and sustain a small microclimate. Isolated from natural weather and insects, a greenhouse may be kept at optimal operating conditions with regular maintenance and care. The goal of this project is to automatically perform this caretaking by utilizing an embedded systems approach. The frequency of maintenance tasks are entirely determined by the present operating conditions. If we can gather relevant information about the greenhouse environment, the microcontroller can do the rest by providing light, irrigation, and fresh air as needed with only minimal human intervention. To construct this automated greenhouse, the following items were chosen with the cost as a primary limitation. The microcontroller will provide all logic and computational requirements, with the sensor providing important data about the environment. A 4-channel relay module was chosen to allow activation of the subsequent climate control devices by the microcontroller. Some problems arose from this specific combination of hardware. As it turns out, the newly released Intel Galileo achieves compatibility with the Arduino platform through emulation. This translates into a heavily decreased I/O speed, which prohibits the use of a small set of devices with extremely low hardware-defined communication protocols. Unfortunately, the DHT11 used in this project is one of those devices. This technical difficulty highlights the importance of choosing the right hardware for a project. As hardware and software are inextricably linked in embedded systems design, our choice of hardware happens concurrent to the basic design of software components. Software will control the activation of climate control devices through a continually tweaked and optimized set of conditions. For instance, this stage of development requires that the greenhouse fan must be inactive for at least 45 minutes before it may be activated again to prevent excessive use. If this is the case, the fan will only be activated if it needs to provide fresh air or cycle out excessive humidity or condensation. Lights will not require sensor input at this time, activating every 12 hours to emulate the rising and setting sun. This is aided by the real-time clock of the Intel Galileo. Now let's see it in action. Because of these long intervals of inactivity and the evolving nature of the timing parameters, this demo will focus on showcasing the microcontroller's ability to interact with the climate control devices situated in the greenhouse.